Okay, welcome everyone to today's webinar. I'm Mike with Inedo. I'm happy to be here, and hopefully we can have a smooth run today. I start recording. Okay, great. We're just going to dive in, and we're going to start with this here slide deck. Okay, so we'll just edit around the notes, I guess. We'll figure something out with that. So I want to welcome everyone to our webinar today. So the topic is DevSecOps, managing risk with open source and third-party packages. Today's agenda is the introduction. I'm going to talk about the state of software supply chain security, the types of vulnerabilities that one might find in the software supply chain, knowns and unknowns, the concept of shifting security far left to prevent vulnerabilities at the source, tracking packages to visualize zero-day vulnerabilities, how ProGit prevents vulnerabilities at the source, and how ProGit tracks packages to track zero-day vulnerabilities anywhere. And then we'll tell you a little bit about Inedo at the end, but I really want to focus on the topic and getting you all the value that you are hoping to get out of this first. So really quickly about me, I'm the COO of Inedo. I've been with the company on and off for many years. I work with a lot of our enterprise ProGit and our Buildmaster users. I do field inquiries from new potential clients. They come in, they want to see, they want to talk to someone about licensing or getting a demo or something to that. I do work with our marketing team in terms of organizing the talk tracks of webinars like this, or the chocolatey webinar we have coming up just next month, things like that. In my personal life, I'm a brown belt in Brazilian Jiu-Jitsu. That is a passion and a hobby of mine. And I have two dogs, Two-Bit and Callista. So they're pretty cool. You can find me on LinkedIn, and I'm happy to connect with anyone and everyone. So just to dive in, so let's talk about the state of the software supply chain security. So we might start with asking, what is software supply chain security? So a software supply chain includes all the components, processes, and tools involved in creating, managing, and delivering software. This includes source code, dependencies, library, and third-party services. We can talk about how the traditional software supply chain security differs from traditional security. So traditional security focuses on protecting networks, devices, and data from external threats like hackers or malware. Supply chain security shifts focus to the components used in software development, such as third-party library, dependencies, and external tools. It ensures the integrity, security, and compliance of the software from its creation to deployment by securing external dependencies, such as open source packages, monitoring code integrity at every stage. And it also is involved with preventing supply chain attacks where vulnerabilities are introduced via trusted third parties. There is a rising threat to the software supply chain. So the Cybersecurity Ventures predicts that the global annual cost of supply chain security attacks to businesses will reach a staggering 138 billion by 2031, which is up from 60 billion in 2025 and 46 billion in 2023, based on 15% year-over-year growth. Attacks on supply chain security are affecting the entire OSS ecosystem and becoming increasingly public and disruptive. Sonatype has maintained an updated timeline of software supply chain attacks since 2017. In their annual state of supply chain, shows how supply chain attacks have increased an average of 742% per year. 66% of CTOs interviewed by Gartner as part of a survey with over 2,000 CIOs planned to increase their security investments, or their investments in cybersecurity in 2024, and we do have that cited, and that is going to be included in the slide deck we send out after this. So on average, cybersecurity budgets accounted for 11.6% of total IT spending in 2023, which was up from 8.6% in 2020. So one might ask, what are common software supply chain risks? These would be vulnerabilities in open source software, which are exploitable, security flaws in OSS components that can introduce security gaps, malicious packages, right? So attackers can inject malicious code into packages that are unknowingly integrated into software. Malicious packages like typo squatting don't last long because a lot of people use and watch popular open source software packages. So if something looks wrong, someone will usually pretty quickly spot it and report it. So this does mean that the bad package is usually found and fixed before it causes much harm. Another source of risk to the software supply chain is tampering with source code, right? Not accidentally adding vulnerabilities or malicious packages is very unlikely. You know, in this case like this, it's usually a insider job and a very skilled person needs to do that. So the attacker would need to very carefully change the code in a way that goes unnoticed by others and still works as intended. So tampering with a company's own source code is again, it's rare. Another source of risk is going to be dependency confusion. So dependency confusion is essentially a type of malicious package. It occurs when an attacker uploads a malicious package with the same name as a legitimate dependency to a public repository. So again, with something like this, someone usually notices it pretty quickly. And then finally, there are outdated components, right? Using outdated versions of libraries or frameworks that lack recent security updates. So with all of these, the most common statistic and likely risk to the software supply chain is vulnerabilities in open source packages. So let's talk about what are OSS vulnerabilities. So while OSS vulnerabilities occur, so just to define it, security flaws in open source components that when incorporated into your application or system can be exploited by attackers. So these vulnerabilities can lead to unauthorized access, service disruptions, or compromised sensitive data. So while OSS vulnerabilities incur unintentionally due to bugs or outdated code, malicious packages are intentionally designed to cause harm. So a vulnerability is a flaw that can be exploited, whereas a malicious package is built with the purpose of exploiting or compromising systems from the start. We'll do a quick couple examples of OSS vulnerabilities in packages. Let me take a little sip of water. So NPM, Lodash, had a security vulnerability related to prototype pollution. In Python, urlib3 or urlib3 had issues with SSL verification bypass. In NuGet, Newtonsoft.json had a vulnerability that allowed unauthorized access to sensitive data. So OSS vulnerabilities like the infamous log4j flaw get into your system when you install software packages with dependencies that contain security weaknesses. For example, when your project relies on a vulnerable version of log4j, the issue is unknowingly pulled into your system as part of those dependencies. So these vulnerabilities are then exploited by attackers who use them to bypass security controls, gain unauthorized access, or access malicious code. So we're going to go into 4 reasons why OSS vulnerabilities are the biggest problem in terms of the software supply chain. So first, there's simply an increase in OSS dependencies, right? 90% of code contains OSS packages. So according to the 2024 Open Source Security and Risk Analysis Report, over 90% of total code bases contain OSS packages, and there's an average of over 500 OSS components per app. Right? When you look at an average application, you'll find that about 90% of code comes from open source dependencies. Most of the code running in an app isn't written by a developer anymore. It's from these dependencies. So in many organizations, developers use dependencies liberally because open source software is incredibly useful. It allows us to build powerful applications in days or weeks instead of months or years, enabling rapid development by leveraging existing high quality software. Another reason is that there is a complicated dependency related to open source packages. So for example, installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers. And what we mean by maintainers is individuals or organizations that are maintaining those packages. The source from that is a paper, it's again linked here, Marcus Zimmerman, Christian Alexander Stachu, and Tani Camprado in Small World with High Risks, a study of security threats in the NPM ecosystem. So this means that every dependency you bring into your project introduces potential risks, right? You're not just trusting the code in that one package, you're also trusting the entire ecosystem it depends on, right? Each individual dependency increases the surface area for vulnerabilities, compatibility issues, and maintenance challenges. So while open source software accelerates development, it also requires diligence in managing and monitoring these dependencies to ensure the security and stability of your application. Another situation is that changes are faster. So with rapid development cycles and continuous delivery, changes are happening faster than ever. And this pace makes it difficult for security teams to act as traditional gatekeepers. So even if changes to your code are limited to just a few lines, your project still relies on numerous external dependencies. So for instance, we talked about if your project uses 79 different dependencies managed by 39 different maintainers or developers, those dependencies are updated from time or every time one of those maintainers makes an update. Your project thus inherits those changes, possibly introducing new risks without you realizing it. So one popular NPM package to look at, for example, is React, which is widely used in web development. Now, React itself doesn't update too frequently. It's limited to a couple major updates a year, but it does have a significant number of dependencies that do get updated regularly. So here's a typical React scenario. So React updates, like I said, 3 to 4 times a year with minor releases and patches in between. But when you start looking at the dependencies of React, React depends on packages like loose envify, object assign, prop types, and some others. So to give you an example, loose envify might get a couple updates per year. Object assign is updated much less frequently, maybe once every few years. And prop types is updated more regularly with patches and minor releases with more frequency. Looks like there's a little bit of a slide was not complete, so bear with me there. But so if we look at it mathematically, multiply the number of updates per year per package or per dependency, and that's the number of changes that are dependent on that single NPM package that is in your code, right? So again, a lot of changes there that are occurring more frequently. Now, we talked about the reason why OSS packages are the main risk to the software supply chain. So let's talk about the solution, and that would be blocking and tracking OSS vulnerabilities at the source. So talking about that in further detail, this is a diagram made by Clint Gibler and Francis Odom, right? In the diagram, the software supply chain security starts from source, and the source in this context is the platform of the source is an IDE like Visual Studio or SCM like Git and source code review. So this is another diagram of software supply chain security. The developer in this case is the beginning of the software supply chain. This is a diagram we created though, and it's a little bit different, right? We don't think the software supply chain starts with Git or IDE. It starts from procuring open source components, the parts that make up 90% of your code. ProGet our tool can block vulnerable open source components before the developer downloads a vulnerable package by acting as a proxy, and it can find vulnerable packages and block them, preventing developers from downloading them in the first place. So unlike the previous diagrams I just showed you, we take action one step earlier in the software supply chain. But there's actually more to just simply blocking all vulnerable packages without exception automatically. Sometimes you want to use vulnerable packages knowingly because not all vulnerable packages are actually exploitable. We'll explain how scanning and blocking in ProGet works a little bit later in this deck. So another item worth mentioning, vulnerability scanners are ineffective against unknown vulnerabilities. So there's a problem of blocking vulnerabilities at the source, right? It only works when vulnerabilities are known to the public. So many vulnerabilities in OSS packages are already known and listed in the public database called the NVD, CVE, and GHVD, etc. Many vulnerability scanners, including ProGet, work by comparing OSS components in your system against the database of known vulnerabilities like the NVD, National Vulnerability Database. Sometimes you incorporate OSS packages in your system and then NVD publishes vulnerabilities. You end up having a vulnerability in your system. So for example, Log4Shell was a great example of that, or not a great example, but it is an example of that. Now, the good news is that when vulnerability information becomes public, and if you have that vulnerability in your code base already, you can figure out where it is and fix it. The bad news, though, is that if you don't know where you have the vulnerability or whether you have a vulnerability or not, you have to take an inventory of your application, and that could be time consuming. It's also worth mentioning that hackers know about the vulnerability because it's public information, right? They don't know that you have the vulnerability because they don't know if you are using, for example, Apache Log4j J2 2.0, but they can randomly attack many computers in a scale, and they might be sharing how to make money by exploiting that vulnerability on the dark web. So the question is, what should you do, right? What you should do is find vulnerable packages in production so that you can assess and maybe fix them. I will definitely be showing you that in the demo that is coming up at the end of this. Here are a couple things you should not do. You should not manually inspect and secure all packages, right? The reason for this is that the volume of dependencies, right? Modern apps rely on hundreds of packages, making manual checks overwhelming. Frequent updates are also an issue where constant updates make tracking every change manually impractical. There are transitive vulnerabilities, right? Hidden vulnerabilities in nested dependencies are difficult to find manually. And finally, it takes specialized knowledge in a lot of cases, right? Manual inspections require deep expertise, increasing the risk of missed vulnerabilities. You also should not manually find affected targets, right? This is not feasible, if not impossible, to manually inspect all applications and server. There's just too many dependencies and updates are too frequent, and you need specialized skills. Some of the other issues are obviously the scale of infrastructure, complex dependency trees, and the possibility of human error, right? Any manual process done by a person, it's just going to increase the likelihood of there being an issue. What you should do is track all packages automatically. And I'm going to show you that in ProGet in just a second, right? So ProGet can automatically track where and which packages are being used and deployed in a CI/CD pipeline and production, and notify you when vulnerabilities are discovered. So like I said, I'm about to show you how that is done in ProGet. So we're going to get into a live demo in a demo setting of ProGet, right? What I'm about to show you are vulnerability management in ProGet. So we're going to show detecting vulnerabilities before they're used in development, preventing developers from using non-compliant packages, automatically assessing vulnerabilities based on definitions, preventing unassessed vulnerabilities from being used in development, and detecting non-compliant packages in release already in production. So let's get into that. I'm going to jump now into my ProGet demo setting. So this is an instance of ProGet. Like I said, it's a demo instance. most organizations are going to have quite a bit more feeds, more packages in use. But again, this is a demo setting. So we have a total of 4 feeds. And you'll note that we do have sort of a admin managerial unapproved feed for NPM and NuGet, and then sort of a dev approved package feed. Now, in a real world scenario, of course, there's axiomatically going to be more packages in the unapproved list than the approved list, and that is because obviously admins or folks in a managerial role will be, they'll have more packages in a queue to look over and approve. Maybe they've been requested by dev, so admins will be looking them over, and they'll have maybe a backlog, or they'll have a list of packages they need to approve, and then fewer than requested, of course, will make it into the approved feed. So again, this is a small demo setting, but I just want to kind of show you the idea that there's the unapproved or the pre-approved, you might call it, and then the approved for use. So we're going to start here with the NuGet approved feed, right? So the admin has said you're allowed to use these. So we have these different packages here now. But if we look, Newtonsoft JSON has an unassessed package. There's a couple of different ways of blocking packages with known vulnerabilities from making it into a build to begin with, or to be used by a developer, in other words, to begin with. It can be done at a policy level, which I'm going to show you in just a second, but it can also be done in a manual ad hoc assessment. So with this one, for instance, this was withdrawn. So this is a unassessed vulnerability that has a ranking. Again, this is sourced from those like national vulnerability databases, right? So the CVE score, EE score is 7.5, pretty high on a scale of 10. So an admin can go in and just say, I am going to say that we should not have devs using a package with a vulnerability at this level. I'm going to block it. And I'm going to put MG blocked. That's obviously my initials, and I'm going to put 10, 31, 24. I can even do an advanced thing and say, we'll reevaluate this on 12.1, but until 12.1, this is blocked. So we can now see, I can reassess it if I want, because I'm logged in as an admin of ProGet at this moment, not a developer. But going back to feeds, just to kind of show you the full cycle here, coming back into here, severe, non-compliant, I click on this, right? I click on the version I want to use, blocked. I'm not allowed to use this. So that's an example there of a manual ad hoc by admin blocking of a package with a manual assessment, if you will, right? Manually blocking a package from being used in the future. But we can also do this at a policy level. There's a couple of different things we can do at that policy level. So, wrong tab. So vulnerability assessment types. We can do a couple of things here. We can, let's just say, I want to automatically block anything that has a high range of vulnerability or a high score of vulnerability. Automatically blocked. Any package that has that score is going to be automatically blocked at a policy level for all devs from here on out. Maybe I want to set at a policy level that we get a warning when anything with a medium severity of risk is used, right? We want to get a notification of that. Okay, we can set that. And then we can also just say as a policy that anything that is low, we're just going to ignore it. So those are examples. We can also create custom assessments, right? So let's say for whatever reason, I want to do a custom blocked assessment, right? And I want to be a little bit more stringent. I want to go all the way from 5 to 10 blocking. I can do a custom range. Now, you would, maybe come up with other reasons or different examples. You could end up creating a number of these different custom assessments, but this is just showing you broad strokes what you could do. Also, of course, you probably wouldn't need to, like these, this custom assessment rules out needing the caution or the blocked in this context, but again, I'm showing you different scenarios that are possible within ProGet. So you would either have something like the all 5 to 10 are blocked, or all 5 to 10 are a warn, or some of these more global policies. So those are examples of how you can do this. Again, for all packages with just broad blankets, again, if it's 4 to 6.9, I want to know that I want to get a warning that it's being used. If it's this high, I don't even want to look, again, as an admin, I don't even want to look at it. It's blocked. So there's also some other things we can do here, because there's also different situations where it's not the vulnerability score that's the issue. It might be the fact that it is a deprecated package. It could be that it's simply unassessed. We don't have a sense of, we haven't made a decision on it. So I'm going to come in here, like I just went into admin, package policies and rule, clicked on the global rule, and I'm going to say that an unassessed package from now on, let me click on it. Oh, got to click on the edit button. I'm going to say that, for example, if it is unassessed, it's non-compliant. Now, you might want to do warning, because you might want to take a manual look at it. We'll do that. We'll do a warn. I think later on when I upload an SBOM, that's going to come into play, but we'll do this. So it's now a warning, right? If it's not an assessed vulnerability, then it's warning. But if a package is deprecated, let's just say that for our rules, we are not using deprecated package in this organization. We can't do it. It's too risky. Now, in all reality, many organizations, because even though a package is deprecated doesn't mean there's anything wrong with it, they might do something more like a warn. But for the purposes of this, I just want to block it from being used. So no deprecated packages, and I get a warning on unassessed packages. So now these are all ways of controlling what packages devs can use in future state, right? What can they use today, or what can they use or not use today for the build that is going to go into the CI/CD pipeline, tomorrow, next week, etc. We also talked about the idea that vulnerabilities are often, packages are often already in production, and then a vulnerability is discovered and then reported. And then you look at the idea that we have this vulnerability, it's in production. How do we know? What do we do about it, etc. So I'm going to kind of round out this demo. I have a software bill of materials. It's an XML file. Now, there's something to be said. I am doing this in this context in this demo. If you have ProGit integrated with leading CI tools like your Jenkins or your TeamCity, you can use a command line to upload these software bill of materials. If you are using our tool Buildmaster, right? Buildmaster has a seamless integration where you can go directly from Buildmaster to uploading the SBOM into ProGit. In this case, I have this XML file because this is a demo setting and I don't have a CI tool linked to this demo setting. But so I'm going to click on Projects and Builds. I'm going to click on Import SBOM. I'm going to copy paste my XML. And I have now uploaded an SBOM of an app. It's called Application Data Reporting. And I'm going to click on the actual build is 3.2.1. And I'm going to analyze it. It's going to run through these different contexts, right? Create and update issues for packages, dispatch notifications when issues are detected, and display detail analysis logs. So I'm now going to analyze it. Okay, it ran through this analysis of the different packages that are used. And we now have this analysis. Here's the packages that are used. Oop, looks like we have an issue. I can look between these two tabs. I can see the vulnerabilities that are listed, and I can see the issue as it is. This is an unresolved issue due to the vulnerability that is on this tab. So I'm going to click in here, and I have the option of resolving this accordingly. So this is blocked because of our policy about the level of vulnerability. So I'm going to click on this and put MG denied vulnerability 7.5 plus, right? You probably won't do the typo, but so click on the resolve, and this is now resolved. This is a failed build, right? This is not able to move to the next step in the software delivery process because of this issue. What we're going to need to do is remediate, use a different package, find a different package that is more suited for this, and then with this, obviously, we want to have record keeping for auditory compliance or regulatory compliance audits, or just sort of our own best practices. We want to export the SBOM into another XML file showing that this was the day that we found this vulnerable package in our build, and we were not, we did not use it because of that vulnerability. We could also change the policy on this package and override it being blocked, and then use it anyway. And then it would be noted that we did that, and we used the package anyway, counter to the policy that we traditionally have, so that is also an option there. So with that, that kind of closes out the demo portion here of our presentation. Just unplug the external monitor so I can kind of get back to my slide deck here. And real quick, so about Inedo, many of you that I saw are already users of Inedo products, but just in case you aren't, so we make DevOps and automation tools. So ProGet is obviously the topic, the product that we've discussed the most in this webinar, but it's a universal package manager and private Docker repository. Buildmaster is a CI/CD platform for application release automation, and Otters for server orchestration, configuration, drift remediation, and infrastructure as code. What we feel sets us apart from some of the other organizations out there is we do not have tier 1 support who are not really able to help our users. They're able to more or less shuffle around the issue to the right people. We have, as a company structure, create an environment where our engineers portion their time between helping our users and developing our tools. So the same engineers that are fielding tickets from our paid users are also the same engineers that have worked on our products for years, or are working on our products in real time. We also are proud of the fact that we do not have outside investment. Our customers are our investors. We keep close tabs with our users to get a sense of what they want and need from the products. We have a great track record with ProGet as an example of some of the different feeds that we've rolled out in the last couple of years. All of those have been sourced from user requests. We work closely with our users in terms of creating better replication, which is an enterprise feature of ProGet, etc. Our tools are also self-managed, so very easy to install and manage. None of that SaaS situation where you log in and suddenly the UI is vastly different than it was the day before, and you have to relearn your workflows that you weren't planning on doing this morning, that type of thing. So it's a self-managed tool. And finally, while we might not have public case studies about them, we have many of our customers are in finance, government, military, and the public sector, and that's exactly why publishing stories of them is not necessarily something we can do. But many of them have regulatory compliance to consider, and they need to prove separation of duties, they need to produce audit trails, etc. We work with many of them, so we definitely have military grade security that is good enough for them. And so if that's something that you and your organization deal with, then you are in the right place when you're looking at ProGet or Buildmaster or Otter. So with that, we're a little bit close on time. Just wanted to really quickly, I'm not the most technical, but I can try to field some questions if anyone has any. And if not, then we can wrap for the day. And like I said, we'll send a follow-up email. But ProGet does, the trial version of ProGet has all of this SCA version in it, as do the paid versions. We do have a very powerful free edition, but the SCA functionality is for the trial and paid edition. So definitely something you can check out if you're not already a ProGet user. So with that, any questions, feel free to put them in the chat, and I'll do my best to endeavor to answer them. And if not, we can also get those into the forums where an engineer will look at them. So please let me know if you have any questions. Okay, looks like, wait, hold on. Go to questions pane. Oh, okay. Okay, so these are comments from earlier. Okay, so, all right. I mean, I'd like to think that this functionality is pretty straightforward and very powerful. So from there, definitely if you're already using ProGet, it might be a good time to start utilizing some of these features in your functionality. Someone just commented, "I'm using this functionality and it's amazing." So that's great to hear. Not a question, but a worthwhile comment. So I think we can wrap here. I do see people are starting to drop off. So thank you very much for your time, and feel free to get in touch. Have a great one.